Good morning, my name's Peter Baxter. This is a presentation on behalf of the FSA, part of the ECA. The FSA is the Fire and Security Association, and this mainly relates to the changes to the 2017 BS 5839 Part 1 standard. There is a little bit of information associated with changes to security standards and also some reminders associated with emergency lighting. I'm part of the FSA ECA technical team, and basically I'm the voice on the end of a telephone. So I answer technical queries associated with fire and security, and the way in which this works is that members will contact the ECA will contact me, and then I will phone the member and do my best to answer the particular query. If you've got any questions, then feel free to answer or feel free to ask. I'll do my best to answer them, and the questions can cover anything associated with fire and security, not necessarily just what's on the agenda today. What we're looking to cover is BS 5839 Part 1, 2017, main changes, some information on PD 6669 2017, and also some information on PD 6662 2017, and as I said, some reminders regarding to BS 5266 2016, because there's some points within that standard which appear to be being missed at this point in time. So, BS 5839 Part 1 2013 is now withdrawn. It was withdrawn from the 31st of August, so from the 1st of September we should be using the 2017 version. There's no period of grace as such. In terms of, in the past, sometimes these standards have run parallel for a number of months, usually about 3, but basically this time the change takes effect from the 1st of September. Probably the most fundamental of the changes is associated with manual alarm call points, where historically they've always been single action, and any change to that has represented a variation to the standard. There is now a requirement in the 2017 standard to fit protective covers. So we now have double action call points. Because in another part of the standard it reflects on the fact that call points are all required to be identical in a single occupancy, they've also made a statement to say that the fitting of a cover does not detract from that statement. So if you fit covers to manual alarm call points, then that's absolutely fine. As long as the base call point behind is the same, then that's all okay within the remit of the standard. Now what this means in some respects is that if you do an extension to an existing building, and it's a fairly substantial extension, then if the building was originally installed to the 2013 standard, those call points won't have covers on, but the call points installed to the 2017 standard in the new extension will have covers on. So you've got a slight difference there. Doesn't make any difference under the terms of the standard, but it might be common sense if you can convince the customer to accept the additional cost of the covers on the other call points. At least everything is going to be the same. But that's a matter of choice. It doesn't conflict with the standard. With regard to manual call points, it's been noted that a lot of call points have been put on doors that lead out to open air but don't lead to a position of safety. Now, this is probably an element of confusion where, in principle, call points should be installed at all exits that lead to open air, and some people have been installing them in places that lead to perhaps enclosed courtyards and things like this. So this is now made clear that this is not required, and the call point should be installed on all exits that lead to a place of relative safety. Clearly, the other issues remain, like, for example, every change of floor level and so on. The need for double pole isolation has been removed, providing safe isolation procedures are undertaken. So this now becomes a matter of choice. Do you put a fuse spur beside the control panel and then undertake safe isolation procedures, or do you put double pole isolation beside the control panel and leave it as it was required under the 2013 standard? So the choice, if you like, remains. But don't forget that the key issue to this is that if you do go back to fuse spurs, then you want to make sure that you adopt the safe isolation procedures. This slide gives a little bit of indication of what's required associated with that. First of all, permission is required to isolate the circuit. Common sense, hopefully, as it's a fire alarm circuit, it should be a single circuit coming from somewhere as close as possible to the incoming main for the building. Locate and identify the appropriate circuit. Then check to make sure that the circuit is actually operational, the one that you're going to isolate. Isolate the circuit, lock it off with the lock-off kit, and verify that the circuit is isolated, rechecking with the voltage indicator. And of course, once you've gone through the appropriate procedure, make sure that that you then recheck the voltage indicator to make sure that the power is okay. These two documents here, which can be accessed from the links which are shown at the bottom of the slide, can give you some useful information on safe isolation procedures if there's any doubts. So these are documents that can be freely downloaded, so please feel free to access these particular links and download those documents if you feel that that is required. One of the other changes is that video fire detection has now been recognised for specialist applications, particularly in L5 type categories and P2 type categories, where you're looking to offer protection to a particular risk for a particular purpose. So it doesn't fall in the normal L1 through to L4 categories where you are particularly protecting defined areas. This would be where you've got a specialist risk that you're looking to protect, and the video fire detection may well be a useful tool in prevention of fire. Basically, these will work on obscuration in the same way that a smoke detector works, and they will also look for movement, and they will look for the characteristics of smoke movement. But these can be a useful tool for specialist applications. One of the other changes, which has been a little bit of a bugbear in the industry in the past, has been how do we communicate through to the fire and rescue service when there is an existing communicator in an existing intruder alarm panel. In the past, various things have been proposed, mainly because the intruder alarm panels will not comply with BSEN 54, which of course all fire alarm equipment is required to be third-party approved to that standard. So that has always been a bit of a problem. And what has been done is that the communicator has been taken out of the intruder alarm panel, put in a separate housing with its own standby power supply. The intruder has been wired in from one side, and the fire wired in from the other side in fire resisting cable. And providing that power supply and the communicator is monitored, then that satisfied the previous standard. What the 2017 standard is now saying is that it's quite acceptable to utilise intruder alarm panels that comply with PD 6662 for the communication. The thing to remember, of course, is that while you can actually wire to the communicator within the intruder alarm panel, and satisfy the standard. What you can't do is wire into a zone of the intruder alarm panel and satisfy the standard, because clearly that zone will be going in on alarm cable which is not fire resistant. So from the fire alarm panel you need fire resistant cable to the communicator, which may well be mounted in the intruder alarm panel, and that is quite satisfactory then to signal through to an alarm receiving centre. Basically, the standard changes, as you can possibly imagine, are mainly associated with minimising unwanted alarms. This is due to additional resource issues associated with the fire and rescue service, quite clearly, and also to minimise the need of fire engines tearing down roads at high speed, which again presents a risk to the public, particularly if it's an unwanted alarm. So what we really want to do is to make sure that all alarm calls that are going through automatically to the fire and rescue service are genuine calls with genuine fires which are requiring either extinguishment or rescue of people. The way to achieve this, particularly with current technology and analog addressable control panels, is quite simple, where, for example, one detector operation could cause a local alarm which is required to be accepted by the responsible person on site. Once this is accepted, it builds in a time delay which gives the responsible person to investigate to determine whether it is a genuine call or an unwanted alarm. And if during that period of time a separate detector or a second detector activates, then the message is sent through to the fire rescue service. If during the course of time a call point is activated, the call is sent through to the fire and rescue service. Or if the person who is investigating doesn't return within the predetermined time, then again the call is sent through to the fire and rescue service. Now, clearly there are some variations on this theme that can be employed, but basically we're being encouraged now to introduce staff alarms wherever technology allows, and wherever we can clearly identify that discussion has taken place to decide what the right period of time delay is, because clearly that can vary from building to building, occupation to occupation. So consultation becomes an important part of that particular decision. And that's now what we're being encouraged to do. There is another annex now which has been introduced to the standard, which is Annex E. And Annex E enables you to go through a series of questions to select suitable detectors to minimise unwanted alarms. Now, while this is a lot better these days than it used to be some years ago, where people, for the sake of saving cable, perhaps in hotels, were running a cable run down a hotel corridor for detectors and then teeing off into a room, and to minimise the length of cable that they used, they would put the detector immediately the other side of the door to the bedroom, and that's right opposite where the shower was. So if there's smoke detectors on the end of that cable, then clearly they're going to go off when steam comes out from the shower, and a lot of these ended up being replaced with heat detectors, which then put the people within the room at risk, because by the time the heat detector went off, you had quite a substantial fire. So while this doesn't happen as significantly as it used to do in the past, there are still design concerns about selection of the appropriate detector for the risk. And clearly, if it starts correctly with the design, then hopefully it's going to end up correctly when it comes to installation and commissioning. If at this design stage it doesn't start correctly, then there's a good chance it won't be installed and commissioned correctly. So a lot of emphasis on selection of the right detector suitable for the appropriate risk. Another area of grey associated with this is rate of rise. Heat detectors have been placed in boiler rooms where clearly particularly on a cold day, the boiler fires up, the temperature does increase fairly rapidly, and the rate of rise detector will go off. And therefore, the sensible thing to do is select an appropriate fixed temperature detector for boiler rooms. Similarly, this consideration might be applied to kitchens and areas like this. So this is what the standards helping you with to enable you to select the right detector for the right job. There was in the 2013 standard a rating table associated with visual alarm devices. That has now been removed, primarily I feel because most people found it confusing, and I'm not even sure if it was correct myself, but it certainly was confusing. And one of the reasons for this is that with visual alarm devices, what we're looking to do is to provide illumination over a given area in excess of 0.4 lux over and above the ambient light level. Now, clearly, our friend outside on a good sunny day, the sun, will produce about 110,000 lux. And if you try and measure this anywhere near a window, then clearly the calculation is a complete nonsense. So this table has been removed. Albeit it does still, the standard does still refer to the test procedures by the LPCB, where they actually tested the visual alarm devices so that they could get approval under EN 54. So what do we do now? Well, basically, with the manufacturers moving forward, we do what it says on the tin. Any visual alarm device should come with a statement on the device, on the box, or on the data sheet, which clearly identifies its parameters for sighting and location. So you might see something that's on the box that says C-3-6. What that means is simply C means ceiling mounted. The -3 means you mount it 3 meters high, or approximately 3 meters high, and the 6 means that will then give you the appropriate coverage over a 6 meter diameter. If similarly you saw something that was W 2.412, then that would simply mean it's wall mounted. You mount it at a height of 2.4 meters, and that gives you a 12 meter cuboid coverage. And that's those are the parameters from the manufacturer that you use at design stage. When it comes to installation and commissioning stage, then there is a requirement for a light meter if you're going to record the actual levels. But it's very important to make sure that you don't do any measurements close to windows and things like this, because you get just totally distorted results. So the thing to do is just to use your light meter to record the light levels within the building or down a corridor or something like this with the visual alarm devices off. Then when the alarms are running, record the same levels again in exactly the same positions and check that you've got an increase of 0.4 lux or above. And that means that you can satisfy yourself that the system conforms to the appropriate requirements. And as I said, quite clearly, you've got to be careful on these measurements to make sure that you don't get distortions associated with the massive amount of light produced by the sun. This is the major bugbear for maintenance engineers. I find this time after time when I'm doing training. There is no documentation associated with the system. And of course, all sorts of things are then raised. Questions like the company who installed the system never actually produced any, the customers lost it, or the previous maintenance company took it away because they decided that they were going to restrict the capability of the company that's now taken the system over. So all not good, basically. Good advice is always provide a document housing. Provide a document housing with a common key so that any of your engineers just need one key to open this. Put all the documents, and give the customer a copy of the key, obviously. put all the documents in the housing, including perhaps the system logbook. Most importantly, make sure that amongst all of the documentation there is a cause and effect, because the maintenance engineer who's coming along to test the system, when he comes along and he's testing detectors, he needs to know if there is any extinguishing attached to the system, whether he's going to bring all the lifts down to the ground floor, whether he's going to shut off the air conditioning, etc., 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 all of which can be most inconvenient for the customer if he gets it wrong, and in some circumstances can be positively dangerous if he manages to discharge extinguishing all over people who are present within the building. And while that might seem funny, it does happen on too many occasions. So documentation, quite important to make sure you get it right. What should it consist of? Well, first of all, a manual on the control panel, a data sheet associated with all the components which are within the system. There should be a specification for the system, i.e. what components are on the system, what's installed. There should be an as-fitted drawing, and as I said, there should be a cause and effect. With that, we should also have a system logbook, and make sure that the client has access to that so that they can record the weekly testing. So this has now been emphasised to a much greater degree, basically because in too many instances it hasn't been happening. The system zone chart. A number of organisations who've been installing fire alarms, particularly with the introduction of analog addressable panels, haven't been placing system zone charts beside the control panel. Their argument is that there is a little text display on the control panel which tells you precisely where the fire has originated from. Unfortunately, from the fire and rescue service point of view, you have to remember that they could be turning up at night. They're obviously turning up to respond to an emergency, so everything's very tense, and they've never seen the building before. So they don't want to be fiddling around looking at your great technology, or perhaps lack of it. They want a very good indication right up front of approximately where the fire is. And as I say, bear in mind, they probably have never seen the building before. So a little diagrammatic representation, whether it's illuminated, which is nice if the customer can afford it. But if it isn't illuminated, just nice colours in a nice frame, nicely produced, nice and simple, showing which area the fire has originated from. When I say area, this will be things like ground floor, first floor, second floor, etc. And you may go into more definition depending on the complexity of the building. Once the fire officer in charge has decided how he's going to deploy his men or women, then he can then consult your wonderful technology and follow the progress of the fire on the screen. The other thing that goes against analog addressable panel programming is that a lot of engineers, and a lot of based on customer advice as well, and a lot of customers put in text like, for example, room 51 or chairman's office or staff canteen. Now, how anyone who has never seen the building before is going to realise where room 51, the staff canteen or the chairman's office is a little bit beyond me. So hence back to the importance of the system zone chart. So please don't forget that, and that was also stressed in the 2013 standard. One of the areas which people are sometimes concerned about, particularly the customer who's having to pay for it, is that where we've got beams or honeycomb ceilings, it causes an element of confusion as to whether this represents a partition or not. Now, the general rule of thumb here is that if the beam downstands from the ceiling more than 10% of the room height, then you consider it as a wall, and that then means that you've got a detector in every single compartment. And similar things apply with, or similar parameters apply when you've got honeycomb ceilings. So if you look within section 22, there is more detail than this, but these two little tables here, table 1 and table 2, give you an idea as to how far the nearest distance should be between smoke and heat detectors. You can see that the distance for heat detectors is in brackets, so the distance between any point and the nearest smoke detector is defined quite clearly in those tables. And referring to that particular section, there is some additional guidance as well. Section 15, as ever, talks about communication with the fire and rescue service. Now, what is different about the 2017 standard is it's now referencing the intruder alarm standards, BSEN 50136 Part 1, and a new document, which is PD 6669 2017, basically are the intruder alarm standards associated with the requirements for communication equipment. So the equipment that is used to communicate intruder alarms and fire alarms needs to comply with these particular standards. Now, under intruder alarms, only self-certification is required by the manufacturer, and as you're probably aware, third-party certification is required for fire equipment. As we saw in a previous slide, that has now been accepted. This self-certification has been accepted from a communication point of view, not from a fire point of view, but from a communication point of view, and hence now the reference to BSEN 50136 Part 1. So that reference is now called up within BS 5839 Part 1. There is also what I see as a bit of an add-on, really, which is PD 6669 2017, which is a new introduction. And this document does add some useful information. The question that sits in my mind is, why have we got another document? To me, it seems it could be sensibly embodied in the key document, which is BSEN 50136. You know, that could be amended or updated if it's felt that parts of PD 6669 are useful, and it looks as though some of them are useful. There is a little bit of a tendency to say when this communication fails, there's a bit of a search for the guilty, which is very true in my experience, because it is a bit of a complicated procedure. If you think about the communication from a fire alarm or an intruder alarm through to the appropriate authority, which would usually be the police or the fire and rescue service, or in some instances perhaps a key holder, or an alarm response company, something like this, then there's so many different interactions that take place. So it starts with the maintenance engineer of the company who are looking after the system. Were the sensors actually working in the event that a call wasn't received? Did the transmission equipment work? Did the monitoring station staff respond correctly? Did the police or the fire and rescue service or the alarm response company respond correctly? And all of these things are in the melting pot for consideration in the event that a call fails to go through. And insurers will be very familiar with this, because they have to investigate this and try and find out exactly what did go on. And in my experience, it's pretty near impossible to come to an accurate determination. So I think this is what PD 6669 seems to be getting at from my overview, is trying to make sure that responsibilities are put in the right place to minimise the chance of this actually happening. We've then got the intruder alarm standard, which is PD 6662, which basically PD means a published document. And for want of better words, that means that it will go. It's not an actual standard as such. It's not a British standard, it's not a European standard, but this published document was utilised from as long ago as 2004, 2005 to introduce European standards into the United Kingdom. Now clearly, if you went to France, if you went to Spain, you went to Germany, everybody does something a little bit differently. So each of those countries will have their own version of PD 666, which, while it embodies the European standard, which is EN 50131, mainly Part 1, but Part 7 is also embodied in that as well, then they also have little clauses which allow them to carry on for the moment with practice which is common to their particular country. And that similar thing applies to us. So PD 666 is the document that introduces the European standard into the UK. That in itself has just been updated. I'll come on to that in a minute. And also it embodies the industry agreement 1501, which was introduced in 2015, which has various content which has been agreed within the intruder alarm industry and then formally embodied within PD 666. From an installer point of view, the main thing associated with this is associated with alarm cable. You may be aware that lots of organisations, wholesalers, etc., have been buying cable from places like Turkey, and the copper content has been reduced to the extent that I tend to call this intruder alarm cable wet string from time to time, and it's becoming more like wet string on a daily basis. So what's happening in fact is the resistance is going up. Now this is not good because, as you may be aware, resistances are used to monitor the fact that sensors exist and if sensors are in the right state. So control equipment is looking for an appropriate resistance at the end of the line, and if the cable is modifying that resistance, then we can get faulty results. So the important thing is to make sure that the copper content remains good, and the requirement here now is that the cable used on intruder alarms must conform with BS 4737 Part 3.30 2015. If we come on to PD 666 2017, while this document came into effect on the 31st of August, PD 666 2010 is not due to be withdrawn until the 31st of May 2019. So that means right up until the 1st of June 2019, we can either use PD 666 2010, which means no change, or we can use PD 666 2017. So the choice remains with the installer. And I guess at the end of the day, we'll just see a mixed reaction to that. There doesn't appear to be anything substantially dramatic which is going to make massive differences associated with this particular change, but at least this is an awareness from that point of view. With regard to emergency lighting, British Standard 5266 was amended in 2016, and I just wanted to remind everybody of some of the basics, because some of the changes don't seem to be being actually employed, possibly due to a lack of understanding. So the major changes within this particular standard were associated with the fact that it previously concentrated on getting people out of the building. It now, question mark, considers people who wish to remain in the building. When I say question mark, you really want to remain in the building, but it does cover that thought process now. Would you want to remain in the building under circumstances where all the lights go out and perhaps it may be on fire as well? So it doesn't beg this particular question. But the main thing that I wanted to cover was the basic requirements of this particular standard. So the basic requirements are, on escape routes, we're looking for 1 lux measured on the centre line at floor level. Clearly 1 lux is not a great deal of light, but it's deemed to be enough light to enable yourself to find your way out to a means of escape. Open areas are generally considered to be areas that are greater than 60 square meters. 0.5 lux is required within open areas. Where we've got high risk areas, which may be something like a varnish vat or some form of production, which is perhaps dangerous and needs to be shut down, then 10% of the normal lighting should be retained, or a minimum level of 15 lux. Now these are the areas where, based on my experience in the recent past, people are perhaps not fully considerate of. Where we've got refuge areas which are increasing on a regular basis, we see them quite regularly now in hotels and quite a lot of buildings where there is more than one level. 5 lux is required as a minimum. Where there is a push bar exit, the panic bar type exit, 5 lux is required as a minimum. And where we've got swimming pools, 5 lux is required as a minimum. So these are obvious areas where people need to negotiate more carefully than just getting out of a building. Commercial kitchens where there may be something going on, deep fat fryers, etc., which need to be made safe before the people leave the building. First aid rooms, plant rooms, fire control panel so that fire control panel can be seen, and reception area, which is usually where the fire control panel is, we're requiring now 15 lux minimum. Again, moving up the scale, 50 lux minimum for examination and treatment rooms, minor operations. Clearly dental practice, minor operations are going on in the dental practice. That would mean that the whole practice doesn't need to be 50 lux, but where the treatment room is, then 50 lux lighting is particularly required in those areas. So I'm now going to deal with some of the questions that have actually come through. I can't actually see. I see I've got a question from Paul. I can't see the actual question. Made a statement, but I can't actually see the question. I can see a question from Gary, who asks, will these slides be available after the webinar? And the answer to that is yes. There will be a video apparently on YouTube. Oh yeah, just to highlight something, there seems to be a little bit of confusion, just to make sure that PD 6662 and PD 6669 are not fire associated. They are associated with security and hold up alarms. So the point I was making there is that BS 5839 Part 1 2017 does now refer through to the intruder alarm standards for communication equipment. So where you've got communication equipment to the fire and rescue service, it refers through to the intruder alarm standard for communication equipment, which is BSEN 50131.
We're going to try and make the PDF available for download.
We're going to make the PDF available for download, are we now?
Yeah. Just give me 2 seconds.
From this site?
Yeah, I'm just going to try to fiddle around with this for a second.
Got a question here from Peter. Can't see it.
Can you see that now?
Okay, thank you. Got a question here from Peter Wood. A manufacturer mentioned updates to EM54 with regard to door hold open devices, but I can't recall the exact issue. Any thoughts? Well, door hold open devices or door retainers are covered under a separate standard. If you look in 5839, it refers to a separate standard associated with door holding devices, it gives a lot of detail associated with where detectors should be sited to operate doors, etc., etc. Quite a complicated question, Peter. Probably not able to answer that in detail on this particular situation, but if you would like to put through an inquiry to the ECA, then I'll answer it under the terms of the technical helpline, because it's quite a lengthy debate. Assuming you remember, Peter. If not, maybe sign up. I've got a question about from Panel Tech as to where VADs are required. Is there more clarity about where VADs are required? Well, with regard to visual alarm devices, historically, obviously audibility has been used for warning of fire, but with the introduction of the Disability Discrimination Act, which was around 1995, then we've got a requirement which says quite simply that we must take all reasonable steps to make sure we don't discriminate against the disabled. Now, this means in effect that where we've got people with impaired hearing, we have to consider that. And it's also worth bearing in mind that people with impaired hearing are not totally insensitive to sound, because obviously sound is air pressure, and people even with impaired hearing will feel that something is going on, but we still need to take additional measures to make sure that they're given suitable warning in the event of a fire. So basic parameters would be this. If the building is a private building where the risk assessment says quite clearly that we do not employ people with impaired hearing, then you might only then need visual alarm devices in areas where anybody could come in unescorted, which might be a reception, which might be a trade counter or something like this, or perhaps in rural areas, toilets close to reception where people might walk in and say, excuse me, do you mind if I use the toilet? And if they're not escorted into those to those areas, then perhaps there's a requirement for visual alarm devices. Where you've got public areas which are open to the public completely, like for example shopping centres, shops, airports, seaports, pubs, clubs, clearly there's a pretty endless list there, then there is no control whatsoever on who's going into that building. There's no question as to whether you've got impaired hearing, etc. So generally visual alarm devices would be required. Equally, where you've got a sleeping risk, then there's another requirement whereby it may be that vibrating pillows are required, because a combination of visual alarms and also audible alarms within a hotel room may not wake someone up who is absolutely stone deaf. So there is a lot of consideration that needs to go on. Some of it based on the risk assessment and some of it based on common sense. just having a look through just to see if I can. So I've got a lot of points here, but and thank you, Colin. Thank you, Steve. Got a lot of points here. I'm just seeing what the actual questions are. I've got a question here from Peter Wood. How do we deal with the requirements associated with low ambient noise at refuges or use of type B outstations, yet refuges being on escape routes requiring sound speech detector heads? Can we use VIDs without audible alarms? Well, if I'm reading your question correctly, Peter, the answer is no. Visual alarm devices are supplementary to the audible devices. They shouldn't replace the audible devices. A little bit like in the construction industry prior to the introduction of the Disability Discrimination Act, where you had high noise levels or people working with ear defenders and things like this. You wouldn't try and defeat noise with noise. Typically, an alarm sounder measured at 1 metre, which is what they do for EN54 approval, at best is going to generate about 105 dBA. Some of the ones which are connected to analog addressable panels will only generate about 95 dBA at source, and we're looking to achieve pretty much 65 dBA throughout a building, or if it's a sleeping risk, 75 dBA at the bedhead. Now, if you're in an area where you've got a lot of noise, manufacturing area, and you've got something like 100 dBA under normal circumstances where people are working, there's no point in trying to defeat that with more sound, because you'll fall foul of the Health and Safety at Work Act, where you'll be actually taking people's ears out. So, got a bit of a problem there, but and therefore you just revert to using visual alarm devices as supplementary devices to the audible alarm. So you leave your audible alarms in and then supplement it with VADs. Not quite sure about the first part of your question, but basically we need to achieve the audibility requirements and also achieve the visual alarm requirements if necessary. Okay, Peter's come back here and said 65 dBA is significantly louder than the 40 dBA maximum required at Type B outstations. Yeah, I see your point there, but of course this is down to the location of the particular sounders, so that you're looking to achieve the sound throughout the building, typically at 65 dBA. There is some variation allowed, whereby it can be down to 60 dBA in normal offices. If you've got a secure area where you've got someone who could be placed in there as part of a refuge, then yes, you would look to make sure that within that area the noise level is reduced, because it's going to be a constant problem for them. I don't think I've got any more feedback on that. Just looking through to see if there's any more questions. Well, Peter's come back and said, is that out anywhere in the BS5839 series, do you know? I think the answer to that, Peter, is no, it isn't. But again, if you are a member and you want to come through on the helpline, I'll have a look through to see what I can find on that to try and answer your question a bit more succinctly, because there's a lot of different things coming into play here. We've got disabled refuge, we've got visuals, we've got audibles, etc., etc. And I'll tell you what it relates to a little bit is that where you've got the fire alarm control panel, you also do not want to have necessarily very high noise levels, because reception areas, which is typically where a fire alarm control panel is where people will be dialing 999. So this is another area of grey associated with the standard, where you would look to perhaps reduce the noise output in the reception area where people might be making a 999 call. So as ever, with all of these things, there are various variations, and common sense has to come into play. But no, there's no real statements which say this is what you must do in this area, this is what you must do in that area. They're all pretty general. See, Paul's come back and said the design can sometimes be better to shut down the source of noise rather than trying to beat it. I don't know if you mean then, Paul, that once the alarm has been given, you shut it down. This depends a little bit on the type of alarm sounding that you've got, I'd suggest. For example, if you've got what I call loosely cascade alarms, where you've got high-rise buildings where you're actually going to perhaps evacuate the affected floor, the floor above, the floor below, and then cause a series of evacuations or pre-programmed evacuations, you've got to be a bit careful about what you do with shutting down the source of the noise. But it depends on the design, and this is where I bring in the question of the cause and effect. Very important to know what the cause and effect is associated with that building. Excuse me. Panel Tech have asked, is there a form for presenting cause and effect as a document? The answer to that is yes, there should be. That's up to the individual company to produce a cause and effect form. A number of companies that I do work for have proper cause and effect forms. Usually they're a sort of matrix thing with a vertical axis and a horizontal axis. And you have on your vertical axis manual call point, fire detector, such and such, and various things. And then on the horizontal axis you will have things like alarm sounders go off, call through to fire and rescue service, extinguishant operated, lift sport to the ground floor, etc. And you put a series of crosses in the boxes which shows what happens under given circumstances, etc. Oh, I see what Paul's saying now. Yes, if under the cause and effect, you would shut down music, you would shut down plant under normal circumstances. You may well bring lifts all down to the ground floor. And again, this is back, particularly from a maintenance engineer point of view, this is back to the question of documentation. This cause and effect needs to be available to maintenance engineers and it needs to be understood by the user. And yeah, that's a very, very important point. Right, the PDF, if anyone wants the PDF, I think Andrew's saying he's going to YouTube it and we'll listen again. If you want to download the PDF as well, you just press the blue button on the right hand side. So on the right hand side of your screen you should have a blue button, and my technical informer has told me that you'll get all of the information straight the way through. So thank you. Right, John's asked, will a link for the YouTube address be provided here as well as the PDF download?
Hi all, we haven't uploaded it yet, so we can't give you the address, but yes, the details have been, we've got the details, haven't we, Peter? So what we'll do, we'll probably send out a generic email anyway, just to say thank you and details to the YouTube link.
And Mark, the answer to your question, Mark Bowman, yes, you do get a CPD certificate. I'm just going to ask how you get it.
Yeah, again, we've got all the details of the attendees, and we should send them an email with the CPD in around 10 days.
Mark, about if you got that, about 10 days, you should get a CPD certificate. And all those people who said thanks for the presentation.